Today we're going to talk about some fun Kubernetes things that I have learned the hard way. A little bit about me. My name is David. My accent is Scottish. I'm from a city called Glasgow. I am the founder of the Raw Code Academy. This is a YouTube channel that focuses on making cloud native and Kubernetes easier for people through series like Klustered. Has anyone seen Klustered before? All right, just a few of you. For the rest of you, it's a live stream that we do quite regularly where you get to watch me cry a lot. I also am the organizer of a new Kubernetes conference in Scotland. Our first one is actually on Monday. It's called Hubble, so I'm looking forward to that too. And generally, my mission is just to make this easier for people. Cloud native and Kubernetes is pretty hard. So if you're here and you're in that space, yeah, congratulations and commiserations. Now, Klustered is a relatively simple idea. It was around 2 years ago where I had this silly idea that I'm quite good with Kubernetes. I've operated Kubernetes now for around 6-7 years. And I thought, how can we help people prepare to do the CKA, the CKAD, the CKS, etc.? And I don't know about you, but I'm a very tactile learner. I don't really learn from reading a lot. I learn by getting my hands on a keyboard and trying to do something. And I thought, well, why don't I do that in a live stream, and then it's available for other people to see how these situations are debugged. And this is really important on Klustered. Like, there are a lot of ways to break a Kubernetes cluster, but we do see repeat breaks. And what's really fascinating is that each person that joins me on the show, they have a different way that they first understand the landscape, so what's wrong, and then start to debug it. And it's actually those thought processes that they share with people on the stream that's more important than the actual fixing itself. The fixing is just something that's kind of mildly entertaining as you go along. So it should be simple. Your mission is to take a deployment, which is running a bespoke clustered application. There's a V1 and a V2. All you need to do is change that deployment from V1 to V2. Easy, right? Well, it turns out it's not that easy. As I said, there are a lot of ways to break the Kubernetes cluster. And what I want to do with this talk is just guide you through some of the core domains that I feel people should be more familiar with when operating Kubernetes and some tips along the way. Now, here's something that I've also learned after, I think we're in 50 episodes. People are very mean. People don't just put typos in config files and call the cluster broken. We've seen people actually downgrade the kubelet on a machine by about 20 or 30 versions. I don't know about you. I've never thought to run kubelet -- version to check what version is run on my cluster. I made some assumptions that clearly we can't make because we don't trust people. We've also had people recompile the API server, actually write their own code, compile it, and ship it onto my clusters. I don't like these people. However, we've had people comment saying, well, these aren't real world. And I actually disagree. Now, sure, human error is a big part of operating Kubernetes. Mistakes happen, typos happen. We revert commits, and maybe we got the rebase wrong. How many times have you had a commit message or a code change that's got those 3 little less than arrows? Happens all the time. But security and your security posture, intrusion, are real concerns. People can get access to your cluster. Now, would they downgrade a kubelet by 20 or 30 versions? Probably not. But would they inject their own API server to log stuff to some remote location? Potentially. So while some of the scenarios and some of the breaks that we've seen may not be something that you deal with on a regular basis, we do need to understand what we're working with. So I'm going to cheat for the next 3 minutes and show you a short clip of an episode of Klustered. You will hear me swear. I'm really sorry. Klustered gets very frustrating, and this was a particularly long episode. But I'm going to show you a small clip just now. Yeah, we still have no clustered DNS. kubedns has endpoint. Okay, that's after 8.
Yeah.
Let's see if Guy wants to jump in and give us a last bit of advice before we wrap this up. Are we close?
You've not looked at the configuration of core DNS. You've looked at the pods, but not how the pods are configured to run the DNS.
We have no DNS. It's always DNS. we miss something? Let's I'm going to say cheat. I'm going to jump onto cluster 14 and grab the config map and see what's different.
What about?
Yeah, these are the exact same file. Yeah. So he told us to look in the core DNS config, and then there was nothing wrong with the core DNS config. That's just cruel. Saying there's a few pixels. If this is a white space error in the core DNS config, I will be mighty frustrated.
It might not be a white space error. Damn.
He's mocking us now because he said your jumping back and forward showed a slight difference. This number seems arbitrary. Oh, you son of a bitch. I'm assuming there's like a weird bug, and I'm sure he's found it because he works at Skyscanner and they've got a level of scale that most people don't have. But something to do with this number going so high is maybe causing it to load an old config map in the pods or something. I don't really know. But the number being so high worries me. But we're now at the stage where I have to go and pick up my daughter. So
yeah,
I'm just going to bring Guy in to tell us what wonderful magical
what we should
crap
do.
this is. Yeah. All right, Guy. Lay it on us.
So when you were jumping back and forth between the working config and the non-working config, if you look really hard at the C in front of it in the Kubernetes config.
Oh, you
bastard. The C?
Yeah, it's not a C. No, it's a character which looks a lot like a C.
What?
So the Kubernetes plugin became authoritative for letter that looks like a C, luster.local.
Hate that guy. Guy's a good friend of mine. He's from Glasgow too. He does work at Skyscanner. He's also the co-chair of SIG autoscaling. So when I invited him on, I thought we're going to get a really cool autoscaling bug. We got a Unicode bug. What I like about this clip is I was beginning to challenge really silly things. I thought that 800,000 was going to cause some sort of integer overflow. Why? Of course, it doesn't make any sense. Like, it's Go. Like, it's not going to happen unless we use an arbitrarily small int. But you get into this mindset when you're debugging, and sometimes you just don't know what to look at. So I think it's just important to highlight that while I have a lot of experience, sometimes if you just don't know the answer, you're never going to see it. Yeah, so there's lots of episodes like that, sadly. Now, there were no rules in Klustered. That has now changed. We no longer allow Unicode breaks. While they were fun the first time, it's not something we want to encourage. And the only other rule in Klustered to date is no saturation attacks. We had one break where they actually filled the disk so the machine wouldn't start. And I can't fix a cluster if the machine isn't online. Yeah, so a couple of rules. But really, if you want to join me on Klustered, feel free to talk to me after. But you can break anything in the Kubernetes control plane. And I'll sit down with someone else from the Kubernetes community. Again, that could be one of you here. And we'll try and fix it on a live stream. Funnily enough, it's quite hard to find people that are willing to sit in a live stream for 90 minutes and fix something when they have no idea what's wrong. OK, so I also think it's important to highlight that failure is just how we learn. I think we need to get better about talking about failure, especially senior and principal engineers. It's really important that we are more public about the things that we don't know, the things that we learn, and share that with people to set better norms in the future. And I'm going to guide you now through the road to Kubernetes. Over the last 50-ish episodes, I've seen lots of different breaks, and I want to distill them down into around 9 tips and tricks across the different domains that you need to understand in order to operate Kubernetes successfully. And of course, we have to start with Linux. Kubernetes runs on Linux. Yes, it runs on Windows. I don't do that. I can't help you with that, but I can help you with Linux. Oh, yeah, I forgot that. This is a much smaller clip, and it's just to set the scene for something, so it's just a minute long, and then I'll talk about what we've just seen.
Free to just go.
Yeah.
Let's get some notes, man.
Let's see. Permissions and
Oh. Let's check.
And you've hit your first snag. There you go.
Okay, make it +X.
yeah. I need my autocomplete stuff. I'm lost.
You didn't install fish while you're here too?
I can type if you want.
Oh,
Okay.
Nice.
okay.
It's an interesting start.
Yeah. Do an ls-l-a on user bin change mod, or probably just bin change mod. Oh, bother! You don't even have tab completion?
No, it's killing me. But hey, we'll make it work.
If you don't, I think that's
Oh wait,
probably because
we
they've
can't
done
No.
mod that.
Yeah,
Well-
exactly. So just look at the whole /bin. Is there anything which is executed at all?
Well, ls is
No.
obviously.
All right. So this was another really serendipitous episode. This was Sidero Labs, who actually have their own Kubernetes-based operating system. So they understand Linux and Kubernetes extremely well. They write their own PID1. All the services on the machine speak over gRPC, and the Kubernetes stuff is all running in containers. It's very advanced, very smart team. The other team that broke this cluster was Red Hat. They also know a few things about Linux. And this was in the first 2 minutes of this episode. And you can see from this screenshot, green is a usual symbol for us that tells us that the file is executable. And if you look at the white ones in here, this is extremely intentional. They have no chmod, they have no change attributes, no kubeadmin, no kube control. Why they stuck OC on there, I have no idea. They have no SCP, so they can't even transfer files remotely back onto the machine. And they have no Perl. Who knows how to fix chmod when you can't execute chmod without chmod? I do now. The easiest way to do this would have been Perl. That would have been what I went for. I suppose you could maybe do this with Python too, but Perl has really close direct support to other executables on a machine, so you can use chmod. However, they removed the executable bit from Perl. You can't do much without kube control, and change attributes is something we've seen on Klustered more than once as well. Who knows what attributes are on a Linux file system? Right, there's like 2 hands. So we all know you can do chmod, which allows us to change read, write, and executable bits, and one other. I won't touch on that just now. But there's also something called attributes, which allows you to modify things at a much deeper level, one of them being immutability. You can actually mark files as immutable. On one episode of Klustered, we've seen someone mark the entire logs directory as immutable. So people were trying to debug a broken cluster going, where are all the logs? And none of the processes could write the logs. That was particularly evil too. So we see a lot of stuff, but it's through this misery that we face on Klustered that we learn really cool things. So how do we fix chmod without chmod? Well, it turns out you can actually use the dynamic linker directly. So you can find the ldlinux.so on a machine, and you can pass it another binary, and it will execute it without checking for executable bit, meaning you can chmod the chmod. So nice tip. File attributes. Once you know they're much easier to understand. You can use ls attribute and change attributes. The only one that we've really seen cause any destruction on Klustered is the immutability flag. So if you ever see that I on the attributes, then you know that some process is not going to be able to write to a file or directory, etc. Now, I said serendipity earlier. There was one other very, very serendipitous episode. There was an episode with Chris Nova. Who knows Chris? All right, a couple of hands. What about Thomas Stromberg? Okay, let me fill you in. Chris Nova is a security researcher engineer currently at Twilio, formerly Google, Heptio, really knows her stuff. Also a bit of a kernel hacker. So we were expecting big things. Thomas Stromberg, also formerly Google, did intrusion detection, was a maintainer of Minikube, and has worked directly on the Kubernetes components. Serendipitous that those two just happened to be on this episode together, but under no other circumstances would anyone else have fixed Chris's broken cluster. Chris was using LD preload to remove syscalls from all executables on the machine, using EBPF to hide a process on the machine that was doing naughty stuff in the background. When you run kubectl get pods, it just displayed a big message saying this cluster is essentially screwed. However, Thomas has done intrusion detection at Google. And the first thing he did on this machine was install something called sleuthkit. And I'm going to ask you to raise your hands one more time, but I don't expect to see any. Who's heard of sleuthkit? Why would you, right? Well, sleuthkit is this really old piece of software that runs on Windows, BSD, Mac, and Linux. It's been used for intrusion detection for nearly 20 years, and it has really cool tools that allow you to get very low level with the file system and the kernel. One of those tools is FLS. FLS will actually take a snapshot of all the changes on a file system for any given period of time. So he logs on, installed sleuthkit, ran this FLS command, and he had a directory with a whole bunch of blobs that told him everything Chris had done in that cluster in the last 24 hours. It was pretty neat. Now, of course, some things are rather opaque. Right? We see that etcd changed, but what changed? We have no idea. So, with regards to modifying systemd unit files, modifying kubelet configurations, API servers, containerd configuration, all of that was just right in front of him. But obviously anything within the Kubernetes API, we still have to revert to traditional debugging techniques. However, FLS is a cool tool, and the fact that it runs everywhere is pretty awesome. You can run that on your own machine. It's amazing how much information you get. You can even see when files have been deleted, and there is the potential to restore some deleted files. But there's a whole bunch of semantics on how that works and whether it will be successful. So that's our Linux tips. We're going to move on to the other dark art of Kubernetes, which is networking. Unfortunately, if you're operating a Kubernetes cluster, you do have to get very comfortable with networking because there's a lot of magic happening, especially with modern advancements in EBPF and XDP through CNI projects like Cilium. Now, if you're using one of these new fancy shiny CNIs, which I assume we all are these days, we have networking V1 networking policies. These are the base networking policies that are in your Kubernetes cluster. And of course, we need to be able to understand them, and those are a good first place to check. However, all these other CNIs now bring in their own custom resources. Cilium has cluster network policies, Cilium network policies and Cilium cluster-wide network policies. And this year, they released local redirect policies. So there's a lot of ways to adjust how your traffic is working within the cluster. What's also quite special about what Cilium are offering is it's not just L4-based policies, but they offer L7-based policies. What that means is that you have actual protocol awareness for a set, HTTP, DNS, I think some databases are supported, where you can actually intermittently break traffic to certain domains or ports, or even block individual DNS queries against a subset of the internet. Lots of stuff, lots of magic, and you might not know where to get started. Next, the thing I hate most about Kubernetes, and there are a lot of them, but this one really frustrates me because it's one of these things that passes the eyeball test. Who's ever changed the DNS policy on a pod? Okay. Well, there's a DNS policy called default. Do you know which the default DNS policy is? It's not default. Why? The default policy actually tells the cluster to use the default DNS resolution of the host, typically systemd resolved. The default Kubernetes DNS policy is cluster first. Now, I hope one day that can be changed, but unfortunately, that's just where we are. And again, we learned this the hard way. Someone changed the DNS policy in a pod. I'm scanning it. I'm going default. Sure, whatever. I trust the default. And of course, we had no internal DNS resolution within the cluster. Also, IP tables is a fundamental skill still, even with some of these eBPF and XDP tools within our cluster. kubeproxy still heavily relies on IP tables or EB tables, NF tables, etc. But there's also another part of the networking stack, which I learned the hard way on Klustered. Who knows what the TC command is? Oh, a couple of hands, there you go. I know now, But the TC command is called traffic control, and it allows you to apply quality of service to different types of requests within your cluster. So what actually happens is someone used traffic control to drop a 95% rejection rate on all HTTP traffic within my cluster. People are cruel. So I'm looking at IP tables, because I know IP tables. I can list all the chains, I can list all the rules, but I had no idea about TC. And then we've got EBPF. EBPF is a phenomenal tool, and I'm going to talk more about it later. But it's also rather opaque. When someone runs something with EBPF in your cluster, you're not necessarily sure that it's there. It's very hard to discover and find, and even harder to tweak and modify unless you know exactly what's been done. But the technology itself is pretty special. Now, if you want to make your networking life easier on Kubernetes, and I know the screenshot's not that big, but it's also not that important. But you have this tool called Hubble from Cilium. This is a user interface that runs in your cluster. Why do we need a user interface for networking? Because you can run kube control, get, netpol, CNPs, CCNPs, that's all the network policies within the Cilium stack, and you'll list them all. But it's actually really difficult to have a visualization of what traffic is actually moving around your cluster. You can read all the YAML, but you're never, I mean, I'm not a visual learner. I can't visualize things in my mind. But this UI is essential, can be essential. So you can see all of the pods, all of the services. You can see arrows that show which ones are speaking to which. And then there's even tools, which you'll see in just a moment, that allow you to modify that as well. So Hubble is a fantastic tool, but only if you're using Cilium, unfortunately. There's also a Hubble CLI. So I like to use Hubble as a UI to understand the kind of spread of services and what's happening. But if I want to be able to start debugging problems, I want to start understanding individual flows, you can drop down to Hubble Observe. Hubble Observe, you can see here we're doing a filter for drop packets, and then I'm doing an additional pipe to grep because I'm looking for things that are messing around with Postgres inside of my cluster. And this was actually a cluster that I broke for the Cilium team. And I used their local redirect policies had been released for about 48 hours, maybe a week at the max. So I threw one in. And what the local redirect policy should be used for is if you want to run like DNS caches across all of your nodes in your cluster so they don't go over the networking stack, then you can local redirect all DNS requests to the local pod. However, I was a bit more sneaky and said all traffic going to Postgres, let's just throw it to FluentD instead. FluentD doesn't listen on port 5432. So they were able to run Hubble Observe and actually find, oh, look, why is our Postgres traffic going to the FluentD pod? So really good ability to understand individual flows. I love the Hubble UI and the CLI, both phenomenal tools. And because Isovalent haven't given us enough awesome stuff, they've given us one more thing, the Cilium editor. So you can go to editor.cilium.io, and you can actually upload your network policy documents, networking V1 documents or Cilium custom resources, and it will visualize them for you. It will also allow you to make modifications to it. Again, it's hard to see on the screenshot, but you can click Allow DNS resolution in this pod, but only to certain domains. Or you can click Allow this pod to speak to this pod over here on this port. So you can get this really visual interface to just point and click, and then you get the declarative networking policy out the other end. You stick it into Git, you set up some sort of GitOps pipeline, and then you're laughing. So I always recommend people use Hubble whenever possible, and even if you're not using Hubble, you can still use the Cilium editor with networking V1 policies. So really, really cool tool. Next, etcd. Anybody like etcd? No, of course not. Well, this is not a real statistic, but as a quick straw poll with the people that have been on Klustered, what we've seen is that any time there is a cluster, an etcd break, people are pretty unhappy because people don't really understand how to operate etcd. We're kind of spoiled because we don't really need to worry about it too much because we have all these managed Kubernetes services now. But if you're doing something on your own bare metal, or you're doing hybrid cloud architectures, then you will probably at some point have to worry about operating etcd. Because it doesn't scale geographically, you have to run multiple of these, and it's very difficult. And I always do a pre-show interview with everyone that joins me on Klustered to try and make them feel less stressed about being on Klustered. But I always say, what's the one thing you don't want to see today? And it's always etcd. Nobody wants to see an etcd break. But they do happen. So I can't obviously tell you how to operate etcd, but I can tell you some of the things we've learned. One is etcd has something called an alarm. Now, etcd is rather configurable. You can specify the quota for the storage backend. So that is, I only ever want to allow etcd to store up to 512 meg of data, and then it will start blocking all writes. This is interesting because kubectl get still continues to work, your cluster still continues to work, pods just won't be scheduled if they disappear, and you can't create any new deployments, etc. But everything appears to be okay except for the write operations. Now, you have to then run it, you have to change the storage quota first, but that doesn't actually solve the alarm. So you can restart etcd with a new quota, there's loads of space, you think things should be working, but you have to manually list the alarms and disarm them every time something happens within etcd. There's a lot of configuration here. You can actually change the max write. We've seen people try to break etcd by pushing down 2 meg blobs to it, which actually does do some damage. But again, everything is configurable, and you can make this work to your own detriment, I guess. It's hard. Number 2, we've seen someone enable encryption on our etcd cluster and Klustered. Anyone know what happens when you enable encryption on your etcd cluster? Your API server can no longer read anything inside of etcd because enabling encryption does not actually encrypt all of the old data. You have to do this manually. Now, there is a nice, easy way at the bottom there where you can enable dual mode, which I'll show you the config for it in a second. But this allows you to support encrypted and unencrypted data in etcd as a migration path. And then you can literally just do a get secrets all, spit it out as JSON, and then pipe it straight into kubectl replace to re-encrypt all that data, which is a nice way of handling it. But yeah, that was a tough episode too. At one point during this episode, I was actually using the etcd command line and manually trying to inject everything into etcd encrypted. It was not a good look. I don't think I have a tip 3 on this, but I'm going to talk about it anyway. And I'll show the YAML config for anyone that's interested. Another really horrible break we've seen with etcd is we spin up our clusters with a single etcd node. So it doesn't run in any sort of high availability capacity. And the breaker just did one command. etcd control member add 0.0.0.0. Not a real IP address. However, that one simple change turns etcd into cluster mode. And then, of course, it's not got quorum because that machine doesn't exist. It never came online. But immediately, I've lost any ability to query or write to etcd at all. You know what the fix is? Delete etcd and start again. You need to have snapshots. Snapshot on your etcd cluster is just crucial when operating Kubernetes. So the only way we could fix that was to uninstall it, reinstall it, restore from the snapshot, and away we went. So there you go. etcd is fun. Now, where are we going with this? This is just a bit of a word cloud from all the breaks that I've seen over the 50 episodes. You can imagine there are a lot of ways to break Kubernetes. We've seen an interesting containerd break. Containerd has a really cool feature called aliasing. This allows you to pull images from an alternative location that are not the ones within the manifest. So what we've seen someone do was run their own container image registry, have containerd forward all requests for Docker Hub to it, and all the images were seeded with bad stings. So every time I thought I was pulling an official Nginx image from Docker Hub, I was actually getting some random image from them. Nothing was working. And it's, again, who knew this feature existed? Well, I do now. We've also seen people swap out the CRI. So most of these clusters are kubeadmin clusters. So they run containerd by default. We actually seen someone replace it with Docker, which sounds fine, right? However, there is an interesting bug or feature, I'm not quite sure which, where we're going to need a little bit more context for this one. Kubernetes control plane has something called a static manifest. A static manifest is a YAML file that lives on the control plane nodes, and the kubelet starts these pods for you. For kube ADM or admin clusters, this runs all of the control plane components, the scheduler, the API server, the controller managers, etc. There's a bug feature with the Docker CRI where if you put the namespace in that to be a namespace that doesn't exist, the kubelet will still run the container. But you can run kubecontrol get namespaces, and the namespace isn't there. You can run kubecontrol get pods all namespaces, and that pod is not there. You actually have the ability with the Docker CRI to hide an arbitrary workload inside of someone's cluster by typoing a namespace. So yeah, maybe not use Docker as a CRI. We've seen a lot of systemd attacks, and by attacks I just mean people run systemd to orchestrate malicious processes on the host, and they give them interesting names that pass the eyeball test, like DNS resolver or systemd debugger or whatever. Things that you skim and you just go, I'm sure that's fine, because who knows all of the systemd components? There's just too many. So yeah, there's lots of things that we've seen on Klustered. And to iterate on what I said earlier, we only learn this stuff the hard way. Nobody sits down reading the Kubernetes documentation looking for loopholes in the Docker CRI for hiding malicious pods. Nobody sits there going, what happens if you downgrade the kubelet 20 versions? It's only when these things happen to us that we learn all these valuable lessons. So people shouldn't feel bad or feel that they are not, capable Kubernetes operators just because you haven't come across this stuff in the wild. And I feel that we have a bit of a problem in our industry with hero culture, and that we celebrate people that work long hours, we celebrate people that seem to know everything, we celebrate people that come in and swoop in and save projects. However, we actually need to dismantle that a little bit. And again, I encourage everyone here in their office to say, I don't know as much as possible, especially in front of junior engineers and people that are learning. So we all find this difficult, and I encourage you, if you want to learn more in public. When you find something cool with Kubernetes that breaks, post it on Twitter. You don't need to type up a big, massive blog post that's 5,000 words. You can even just share a gist and post that. But it's only through, we all have our own unique circumstances. Our own production looks different. Nobody's production is the same. We're always going to run into different things. So I encourage you all to share as much as possible. Now, what am I learning next? Well, I mentioned EBPF earlier. I genuinely believe this is the most valuable thing that anyone operating Kubernetes could be learning right now. At least this is my opinion. And the reason that I believe this is, well, it gives us the ability to run arbitrary code within the kernel. If you remember monitoring any Linux system, I'm not even talking about containers and Kubernetes now, anything. We used to have agents for PHP, we had agents for Ruby, we had agents for Python. All of these different runtimes needed instrumented differently. However, with EBPF, because we can hook into the kernel and the syscalls, we can actually understand all of these runtimes with a single language. So we no longer need to go and get the Datadog PHP agent. We can just install some sort of EBPF agent and then have it write to some location. It also gives us the ability to understand tracing within our kernel, so we can get networking understanding for latency for all requests. It's really just a little bit magic. It's also safe and secure, although this is being challenged by people trying to break it as often as possible. But we essentially we're encouraged to believe that we have a sandbox within the kernel that will never crash because of the restrictions the kernel places on the language that we use to write our EBPF programs. Now, we already have a lot of EBPF out there already. I mentioned Cilium a lot. It's a fantastic project, and it relies heavily on XDP and EBPF. Falco from Sysdig is another really cool project. It allows us to write rules to actually monitor for our syscalls being run across all of our cluster. So you know your applications better than anyone else. You know what your application is supposed to be doing. Should it be binding a socket on a low port number? Probably not. So we can actually monitor for this. Now, of course, hopefully we have runtime profiles that don't allow that at all, but I haven't seen a lot of that in the wild. So using Falco to understand what's happening within your clusters and having that log these rules somewhere just gives you a lot more visibility. Inspector Gadget by the team at Convoke, now at Microsoft, is another awesome project. It gives us tools to actually debug and work with our cluster as well. It will allow you to run code within pods to monitor for ports. What if it's an application running and you don't know what port it's on? I mean, we all set the container port in our pod, but do you know it does nothing? Nothing at all. All it does is provide an alias, so that in your service you can use the port name rather than the port number. But that doesn't allow the pod to open something on that port, and it doesn't actually affect any traffic. So it could say port 80, but your service is actually running on port 4000, and you would never know. The Spectre Gadget gives us a tool where we can actually say, listen for all binds in this pod and tell me what ports get opened, and it spits them straight back out. I actually broke a cluster for EBPF Day last year for the Microsoft team. And I changed the port to see how quickly they would get it, and they fired out their Inspector Gadget bind tool pretty quickly. Pixie is a really cool project. It's open source, but they were recently bought by New Relic, so I don't know what that means, but Pixie is really cool. It gives you monitoring for all runtimes by just running EBPF code. It exports Prometheus endpoints. You can scrape it all. You don't need to change your code. It hooks in at the kernel level. Now, what is quite common with all of these tools is that they layer on and build on top of the BCC or BPF examples. So there is github.com/iovisor. There's a project called BCC. It has a whole bunch of tools. I think there's at least 30, maybe even more, but some of them are listed here. Exec-snoop. You can run exec-snoop on any Linux machine, and it will tell you every time someone executes a command. You can filter that to look for processes that have the set UID bit as 1 or sudo, so you can actually emit events every time someone elevates their privileges over on your machine. Or you could just look for people running kubectl and spit out something in Slack going, hey, someone just ran kubectl, what are you doing? Entirely up to you. There's also IO-snoop. This will allow you to monitor all file operations within a machine without having to instrument anything as well. There's OpenSnoop, which shows you every time a process opens a file. So you can see we're getting all of this visibility that we just didn't have access to before. And then the 3 at the bottom are the TCP stuff. You can actually monitor all of the TCP traffic within your cluster with a single command. So these tools are just phenomenal. And I believe EBPF does change everything. Do we have time for the demo? No. I'll keep time for questions. But if you want to see a demo of EBPF, I do have these labs available here on Instruct, which give you a real Kubernetes environment, and the challenge is clustered. So if I export my kube config and run kubectl get pods, we have a broken Kubernetes cluster here. I prepared 6 of these. They're not publicly available yet, but my plan is to do that really, really soon. But if you feel like a bit of a challenge while you're here at the conference, drop me a DM on Twitter, see me walking around, come up and speak to me, and I will get you access, and you can try and work through these challenges yourself. Some of them are easy, some of them are cruel, so just check it out and let me know how you get on. Yeah. Now, this is the Kubernetes risk pyramid. What I'm trying to show here is that EBPF allows us to instrument and understand every layer in this pyramid. Now, the highest risk we have with operating Kubernetes is at the Linux level. Most of the attacks are going to try and attack the host rather than coming through the workloads on the cluster. However, that is also potential. And EBPF gives us unparalleled observability into that Linux kernel. Imagine using bind snoop and exec snoop and monitoring for specific syscalls on that host and logging them somewhere. Again, you probably know what kind of commands and things you expect to run on your machines. So really tailor that to make sure that you have intrusion detection across the entire Linux stack. Moving up the pyramid, we have lateral movement from a pod. Should someone actually get access to your application, we hope that they're stuck in that container and they can't do anything. However, we do have things like default service account binding, which may allow them to speak to the Kubernetes API. And depending on the privileges and runtime security profile for the pod, they may be able to do more. So make sure that you understand and apply network policies whenever possible, because this is how you're going to get detection for that lateral movement. Why is this pod suddenly speaking to my API server if I don't want it to? Or why is it sending PG dump commands to a Postgres container that it shouldn't be speaking to? So just make sure that you understand that landscape. And then the lowest risk, but the most dangerous risk is, well, what if we have a container breakout? And again, it's only through runtime profiles and tools like Falco that we can actually get real-time detection for that. Now, container breakouts are extremely unlikely as long as you apply all the sensible defaults. However, it is still a risk that we need to be aware of. If you want to learn more about eBPF, Brendan Gregg is really driving the awareness of this project forward and building some really cool tools on top of it. So check out Brendan Gregg's blog. I've already mentioned the BCC project, but there are lots of examples in that repository. So if you've got an idea for a tool that could leverage eBPF, like the one I use a lot is just check for sudo access and kube control access on a machine and have it logged somewhere. You can go to that repository, go into the tools folder, you'll see the exec snoop. It's Python code. You just start hacking it to only filter for the commands or the processes that you need, and then you run that eBPF program across your infrastructure, and you get this observability. Now, eBPF Kit. This one is dangerous. This is from the team at Datadog, who decided, well, eBPF gives us interesting powers within a machine. Could we build a rootkit with it? The answer was yes. This is our, I'm not going to say 100% because I can't say 100%, but I can say 99% undetectable rootkit using eBPF. It's very difficult to understand this is running on a machine through traditional tools. You actually need more eBPF to understand if there's other eBPF happening. But you can check out this project, and there's some demos on YouTube where they walk through it at conferences, but it's just scary and exciting, that kind of cross-section between the two, but very cool project. All right. So I would love to speak to people afterwards and know what yous are learning and what yous find interesting. There's a lot out there. We've all seen the CNCF landscape, right? There's lots of tools. There's hundreds of tools, maybe even thousands of tools. So while eBPF is interesting for me, I'm always curious to see what other people are learning and what they're finding interesting too. Thank you so much for your time. I'm happy to take any questions. That's it. Thanks. Any questions? Oh, yeah.
Have you looked at Tetragon yet?
Have I looked at Tetragon yet? Yes, I have. I know there's been a lot of, not complaints, but maybe backlash against Isovalent for releasing a product that doesn't quite do what they say. However, I think it's a really good first step, and I'm excited to see where the project goes. I think it is going to bring a new level of understanding to things happening in our cluster. So I'm excited by it, and I played with it, but I haven't deployed it in production yet.
Cool.
Have you?
We are looking at it.
Nice. Yeah.
What do you think of kind of service mesh level kind of things like Istio and Linkerd, and how do they really help with that kind of controlling the network traffic for the cluster?
Yeah, so the question was, what do I think about service meshes? You mentioned Linkerd. Do they help us understand and control traffic within a cluster? 100%. I use Linkerd in every single cluster because you get automatic MTLS between all of the connections within your cluster. And I think that's really important. We always have this concept, or we have this naive assumption that traffic within our cluster is safe, but it is really, really not. So enabling MTLS should be the first step on any new production cluster, and I recommend most people try out Linkerd. It's the easiest approach. There are other ones, of course. There's Istio and there's Glue, but Linkerd from an operations point of view is just a Helm chart away. So, yeah.
You mentioned default service accounts and compromised pods having access to the Kube API. I've tried to look into this, and I don't really see why they would have default access.
Haha, good question.
Why do they have that?
So the question was, I mentioned the default service account earlier. This is a token that is mounted into every single pod that allows you to query the API server potentially. This was actually removed in Kubernetes 125. So there, you will no longer get default service accounts mounted into any pod on modern Kubernetes installations. But all older clusters do get this behavior. I don't know why. I think it's been removed for a reason. We don't want arbitrary pods being able to speak to the API server, so it's a really positive change. And we're seeing lots of changes like this, right? Kubernetes for the last 2 years, I think every release is bringing better defaults to Kubernetes clusters, and we're taking security a lot more seriously within the community. With pod security policies being deprecated, but new runtime defaults coming in, we're seeing more adoption of seccomp. Like all these things are coming. And I think over the next 2 years, things will be much more sane by default, hopefully. No more? All right, thank you for your time.